Moving along, that was the Red Cross. We have the hurricane hazards presentation now from the National Weather Service. Scott?
Okay, thank you. Good afternoon, everyone. My name is Scott Spratt. I'm the warning coordination meteorologist from the National Weather Service in Melbourne. I've been at the office for about 18 years now, and presently lead the warning services for the office. And I appreciate you all taking the time to be here this afternoon. We've heard a lot of great information about hurricane preparedness today and emergency communication. And now we're going to shift gears a little bit and talk about the science or the meteorology of hurricanes and hurricane forecasting. So I'd like to cover 4 main topics today. I'd like to talk, first of all, about the mechanics of hurricane forecasting, how do hurricanes form, how do they intensify, where do they move to. I'd like to talk about the individual hazards that occur within hurricanes. Most people think hurricanes, they think of wind, but there's also the hazards of tornadoes, flooding, and if you live near the coastline or near the intercoastal rivers, also storm surge. I'll talk about a few products or services that the National Weather Service and the National Hurricane Center offer to help you better prepare for hurricanes and to keep abreast of those individual hurricane hazards as they approach your area. And then I'll wrap it up by talking about, I'll give a current weather briefing, a tropical weather briefing on what's going on today. It's starting to get a little interesting out there in the tropics today. And I'll give an outlook for the remainder of this hurricane season. First of all, just talking about the conditions that we need in place to have a hurricane or tropical cyclone form. Anywhere in the globe, you can see the map there of the entire world and the different locations around the globe where hurricanes or tropical cyclones form. We need 5 ingredients for that to occur. We need a warm water to a deep layer. This is not just the surface temperature of the ocean. A lot of times you'll see weather buoys maybe on the internet and see surface temperatures. We need the water to be through at least 100 foot, 150 foot layer from the top of the ocean surface down below to be 80 degrees or above to have a tropical storm or hurricane form. So that's the first ingredient we need. We also need the atmosphere to be unstable, and we need sufficient moisture within that atmosphere. And these 2 ingredients really shouldn't be a surprise to anyone here because those are the same 2 ingredients we look for day in and day out for general thunderstorm formation. So the last couple of days here, we've been missing one or both of those ingredients because we haven't had any thunderstorms here on the coastline. That's going to change over the next day or 2 when we have more moisture and we have more instability in the atmosphere. We'll start to get back to our daily thunderstorms. We also need those same two ingredients within the tropical environment to have a tropical system form. We need low vertical wind shear. And wind shear is changing wind direction and or speed with height in the atmosphere. So as you go up in the atmosphere, the winds, the lesser they are changing in wind direction or height, the greater the potential is for low vertical wind shear and hurricane development. And finally, the last ingredient, we have those first 4 ingredients being in place. But if we don't have the last ingredient, we're not going to have the beginnings of a tropical cyclone. And the last ingredient is a pre-existing disturbance near the surface and away from the equator. If you notice in the graphic there, within about 100 miles of the equator, tropical cyclones do not form. That's because the cyclones need to spin from the Earth, the rotation of the Earth, that's imposed upon a developing cloud cluster. And that spin from the Earth helps the disturbance to begin to rotate. Well, there's no spin acquired from the Earth within about 100 miles of the equator. So if you live in Florida and you're sick and tired of hurricanes, want to get away from hurricanes, you need to move within about 100 miles of the equator. It doesn't mean they don't have storms there. They have thunderstorms, but they don't have organized, large-scale areas of rotation that can occur there. And of course, the closer you get to the North Pole or South Pole, the waters are too cold for tropical formation. So in between those 2 zones, away from the equator and away from the poles, is when you have that tropical cyclone development. The pre-existing disturbance during the beginning part and end part of the tropical season tends to be a cold front that moves off the continent of North America. Maybe it comes down to the northern Gulf Coast and maybe to the Florida coastline and stalls out in that location. When it stalls out there and thunderstorms percolate in association with that front, we eventually can have the beginnings of organization in the tropical cyclone. The last storm that formed, Cindy, that formed off the coast of Florida a few weeks ago, formed in that method. A cold front came down, swelled off the coast of the Gulf of Mexico, the east coast of Florida, and eventually it took 3 or 4 days, and an organized storm system formed there, it became Cindy, and moved out away from us over the open Atlantic. During the heart of the hurricane season, the pre-existing disturbance tends to be easterly waves, or tropical waves, that form over the continent of Africa. Sometimes they form as far east as the Arabian Sea, around Ethiopia. And they move all the way across the continent of Africa. They come off the coast of Africa, right around the Cape Verde Islands, and they move all the way across the tropical Atlantic for maybe 7, 8, 9, 10 days before they get to the North American continent. And they have all that time to intensify and become strong. So those are the ones we look for during the heart of the hurricane season, usually in September. They can be the biggest storms that approach Florida from the east. This is a composite of about 100 years of tropical storms, hurricanes, and typhoons across the world. And of course, typhoons are the same thing as a hurricane, it's just a different name, a different part of the world. They're both tropical cyclones. Tropical cyclone is a parent name for any type of organized tropical disturbance. So a tropical depression, a tropical storm, and a hurricane are all types of tropical cyclones. And again, from this graphic, you can see the devoid of formation near the equator and the poles, but right in the middle you see all the development in those areas. And since it's a composite of 100 years laid on top of one another, the brighter colors that you see there indicate the higher occurrence of stronger tropical cyclones. And where you notice all the bright red colors, they're across the western Pacific. That's the area that has the greatest amount of tropical activity around the whole globe. Second most is over the eastern Pacific, and third most is over the Atlantic Ocean. The hurricane season. The hurricane season is 6 months of the year, so half the year we're in hurricane season, from the 1st of June to the end of November. But if you look at this graphic again, a compilation of all hurricanes over a number of years, it's about 100 years of data. And we're looking at tropical storms in red and hurricanes in orange. You can see that although the hurricane season begins officially June 1st, things really don't start to ramp up until we get into about the first or second week of August. So we're just about to approach the season, the time of year where things really start to get active across the tropical Atlantic. And if you look for how quick those values ramp up from the first or second week of August, and they peak around September 10th, and then drop off very rapidly after the early to mid part of September, you can see that a lot of people, we get into June and July, and there may not be a lot of tropical activity, and people tend, even the news media tends to say, okay, maybe that forecast, that seasonal forecast by Dr. Bill Gray or by NOAA isn't going to be right this year, and maybe we're not going to have a bad season after all. There's a very, very low amount of correlation between the amount of activity we have very early in the season and how active the entire season is going to be, because most of the activity does occur from the middle of August through the month of September and into October. And this graphic spells it out really well. Some numbers I want you to remember. An average season consists of 11 named tropical storms, 6 hurricanes, and 2 major hurricanes. So that's kind of the benchmark you should always remember. That's an average season, 11, 6, and 2. On an average season, the first tropical storm isn't named until the 10th of July. The first hurricane not until August 14th. And the first major hurricane, which is a category 3, 4, or 5, or winds over 115 miles per hour, not until we get into early September. So far this year, anybody know what we've had for tropical storms? We just had the 4th one, Tropical Storm Don, so we had 4 tropical storms so far this year. No hurricanes yet. The first tropical storm, Arlene, came close to reaching hurricane intensity. It got up to 65 miles per hour. It needs to be 75 miles per hour to become a hurricane intensity. But it just kind of puts things in perspective, because although we can have a relatively slow start to the season, that's really average, that's typical. Things really don't start to get going until we get into August and September. I want to talk about the Atlantic multi-decadal oscillation, the big mouthful, the AMO. The AMO really is the amount of activity that we have across the entire season over the North Atlantic. And the AMO is a 30 to 40 year fluctuation of ocean temperatures across the North Atlantic Ocean. And if you look at the graphic in the upper left, this shows the years in which the North Atlantic Ocean had warmer than normal sea surface temperatures in red, and then colder than normal sea surface temperatures in blue. And you can see an oscillation or a fluctuation in these 30 to 40 year time periods. We go all the way back to the mid-1800s. using records from shipping captains. And we see warm ocean temperatures back then, and then a 30 to 40 year cycle of colder than normal North Atlantic temperatures, back to warmer, colder, and then back to warmer starting in 1995. We switched from cold in 94 to warm in 95. That began the 30 to 40 year current period of warm sea surface temperatures across the North Atlantic. And if you look in the bottom right, this indicates the amount of intense hurricane activity near Florida when the water temperatures were warmer than normal or colder than normal. So the area in blue there on diagram A shows the intense hurricanes, categories 3s, 4s, and 5s, when the sea surface temperatures across the North Atlantic were in the cold phase. And there's some there, so we're not saying that even in a cold North Atlantic year that we cannot have a landfall of a major hurricane in Florida. It can happen. But if you compare it to the number of hurricanes when the North Atlantic was warm, in diagram B on the right-hand side, there's a lot more of them there, indicating a much higher potential for us to get a major hurricane near Florida when the sea surface temperatures are warmer than normal. So that's factor one, to indicate how busy a particular season will be. The second factor we need to look at is the state of the El Nino. Now, El Nino is a warming of the Pacific Ocean that moves from the western Pacific to the eastern Pacific. The eastern Pacific usually has very, very cold waters off the coast of South America. And these cold waters cause stable air mass and suppress thunderstorm development. So if you look at a satellite picture, most of the time off the coast of South America, off the western coast of South America, you don't see any clouds. It's a very, very stable environment. Well, during El Nino year, that warm water travels from the western Pacific to the eastern Pacific. It displaces the cold water. Now we have warm water sitting off the coast of South America. And just like over warm land over the Florida Peninsula in the summertime, over warm water, thunderstorms develop, which is normally a very dry area, so now we have thunderstorm development. And as those thunderstorms develop and get up to 50 or 60,000 feet in the atmosphere, they have a feedback mechanism that changes the wind flow of the jet stream. So El Nino is an oceanic phenomenon. It's warming waters of the Pacific Ocean. But it feeds back to the North Atlantic atmosphere by causing higher wind shear across the North Atlantic Ocean. And if you remember earlier, we said tropical cyclones need low wind shear to form. If a high wind shear is occurring, the diagram you have on the right there shows that the clouds that are trying to develop vertically upward get tilted over a little bit. And then when they get tilted over, the mechanism that causes a hurricane to form and have the eye of a hurricane form cannot happen because the thunderstorms are tilting on the side, and the eye can't develop and become maintained. On the other hand, if we have low vertical wind shear, like in a La Nina year, La Nina is the opposite of El Nino. It's colder than normal water temperatures across the eastern Pacific. We have low vertical wind shear when the thunderstorms and hurricanes can form. So that's El Nino and La Nina. One more term to remember, neutral conditions. Neutral conditions is between the two extremes. So between El Nino and a La Nina is called neutral conditions. Now look at the bottom right-hand diagram. An average season in the North Atlantic on the left-hand side would be 6 hurricanes. That's the first bar chart on the left-hand side. But if we have an El Nino, either a moderate El Nino or specifically a strong El Nino, like on the right-hand side of those bar charts, we have a suppressed amount of hurricane activity because of that high wind shear. Well, if we have a La Nina, or especially if we have neutral conditions, we have low wind shear and a higher number of hurricanes across the Atlantic. So the two factors work together. What stage of the Atlantic multi-decadal oscillation, the AMO, are we in? Are we in a warm cycle or a cold cycle in the North Atlantic? And what is the phase of the El Nino? Are we in an El Nino, high wind shear, a La Nina, low wind shear, or neutral?